Hello 108 class, Mr. McHugh here with you. We're going to wrap up section 8.7 complex numbers. Page 4 we're going to tackle in this video, and we're going to go ahead and multiply two complex numbers, aka multiply two binomials. We're going to look at example 6b, and we're going to remember for one more last time I squared equals what class? Negative 1. Every time you see an I squared, you're going to replace it with negative 1. Okay, so that's what's new. And so if you multiply two binomials, you use the FOIL technique and work our way through the paces here. You can say 3 times 4 is 12. First, outer would be 3 times negative 2i. Is right here. Inner would be 5i times 4. Now I'm writing these all out in painful details. Last is 5i times a negative 2i. So I write them out in details, I execute, multiply, 3 times 4, 12. Negative 6i, 5 times plus 20i, and finally, watch this, negative 10i squared. 5 times negative 2, negative 10, I times I squared. Okay, now here's where your I catches I squared. What do you replace it with? Negative 1. Okay, you've done that. What's negative 1 times negative 10? Positive 10. You got it. Okay, now look what happens. Combining like terms. 12 plus 10 gives you 22, and you bring down the 14i, and you have your complex number, and there's your answer. So when you multiply a complex number by a complex number, you usually are going to get a complex number. Okay, I say usually because, what happens if you go back and visit the famous binomial and you multiply it by its, okay, you can see the words conjugate, which says take the first term, second term, leave them the same, and do what with the signs? Switch them, change them from positive to negative. Okay, now, what happens if we do that when we have got not just a binomial, but a special binomial called a complex number? We're using the letters A plus BI to represent the real part and the imaginary part. Going to multiply by the conjugate. Okay, now here is the lawyerese writing here, so let's just follow this real quick. FOIL first time, A times A squared. Last, A times minus BI is the O. Inner, now you know when you multiply a binomial by its conjugate, you're using the difference of squares, but I'm using the FOIL technique just to prove it to you one last time. Here's your inner product, BI times A, and finally last, BI times a minus BI would be negative B squared I squared. Okay, now you've got that. The O plus I, the outer plus the inner, always cancel each other out. They add up to 0. Okay, so they're gone. So you got A squared. Now watch what you got. Negative B times I squared, which is negative 1. So a negative times a negative turns it into the formula A squared plus BI. Okay, now they want you to memorize that. I don't know if you have to memorize it. You just have to remember that it's the difference of squares works a whole lot easier for you when you do these problems. Take the first term, square it to get your answer. Take the second term, BI, and square it, and it's going to turn out to be a plus BI. So it's A squared plus BI. Okay, now the reason they're showing this for you is let me see if I can squeeze this in here real quick. What if I gave you 2 plus 3i and we multiply by its conjugate 2 minus 3i? Okay, so let's take the first term and square it, 2 squared. Then let's take 3i and square it. What do we get? 4 plus, 3 squared is 9. 9. I squared is negative 1. I'm running out of room. 4. This is what? 4 minus 9, and you finally get negative 5. Okay, so I guess I'm trying to get you to see here is that when you multiply a complex number by its conjugate, you end up with just a real number. Okay, now we're going to take advantage of that fact because on the next problem down here in example 7a, we start off with this. We're going to divide a real number by, we're going to divide a complex number by a complex number. Okay, now, what am I supposed to do with this? Well, to help you out, what you want to remember is, just like we don't care for radicals in the denominator, we now don't care for i's, or imaginary numbers, in the denominator. And the way to get rid of the I is to multiply by the conjugate. I'll put the little letter C there to remember. So you take 5 plus 2i, write its conjugate down, stack it because it equals 1. Anything divided by itself equals 1. And you're going to go ahead and multiply. You're going to multiply the denominators. And so the shortcut is to take the first term, square it, which is 5 squared. Take the second term, 2i, and square it, which would be 4i squared. And excuse me, I'm just double checking here. I think that should be a minus here, right? You got 2 squared is 4, then you still got I squared, which is negative 1. I missed that on my notes here. Okay, so this should be a minus 29 here. Or, I mean, excuse me, 25 minus 4 would be, this should be a 25. Oh, how about that? Okay, I got to check that for a second here. I'm sorry, getting hung up in details here. I should have double checked it. So you multiply, let's get back to the problem to make sure you know how to do it. You're multiplying the binomial by its conjugate. Okay, you're going to get I squared is going to equal negative 1. And up here you're going to go ahead and use FOIL and do first outer, inner, last. You can see the details here follow, and you're going to get 40 plus 18i giving you 58. Negative 16 plus 45 is going to produce the 29. Okay, now I don't know. Yeah, this is the problem. This is the same problem. This just should be 5 squared plus 2 squared. Oh, it's because it's a plus. That's right. I'm sorry. It's always a plus. Remember the rule up here. It's a squared plus b squared. I apologize about that, class, making life harder than it has to be. So 25 plus 4 is 29. That's all correct. And once you've multiplied across the numerator, you did FOIL, reduced it down. You now have 58 divided by 29 produces the 2. 29 divided by 29 produces the 1i. And there's your answer. Okay, sorry to make that harder than what it needed to be. We're left now with our last objective here, powers of I, and you need to learn this idea that I is equal to I. Fine. If you that's I to the first equals I. If you have I squared, and we've already shown it equals negative 1. I to the third would be I squared times I to the first. Here's the dirty work over here. That would be negative 1 times I. So there you go, negative I. And then this is the key one, I to the fourth. What would that be equal to? I squared times I squared. See how we're breaking them down by, when you multiply by the same base, add the exponents. 2 plus 2 is 4. And so I squared is negative 1 times another negative 1 produces a positive 1. So I to the fourth equals a positive 1. This is a key, another transition to go from imaginary into the real world, and you're going into a I to the fourth equals a positive 1. Okay, so you want to learn that. Okay, now the reason why they do these, they're going to give you some of these examples where you're going to have the variable I, and it's taken to the exponent as I to the 12th and I to the 39th, and how you're supposed to handle them. Okay, and the idea here, come back down and look at this one, I to the 6th. What would that be equal to? What you're going to find out here is when you take out I to the fourths, you're going to always take out as many I to the fourths as possible. That's going to produce a 1 value, and you're going to be left with either negative I, negative 1, or positive I for your final answers. Okay, those are your 3 choices. So you just got to do the factoring correctly. So what you do here is look for factors of 4. So I to the 6th, I'm going to break it down. I to the 4th times I squared. 4 plus 2 is 6. I to the 4th equals 1. And so I've got 1 times I squared, which is negative 1. I squared is negative 1. Final answer, negative 1. Okay, so up here, I to the 4th, one way to separate it was, I said I times 4th, I to the 4th times I to the 4th. Another way to do this problem is to realize I to the 4th raised to the outside exponent of 3. 3 times 4 is 12. Remember that that's your power rule. Inside outside exponents, multiply them. So you want to take I to the 4th and get as many factors as you can, and what you're left with, then that's going to decide your answer. Okay, now this one happened to work out even, so you get 1 times 1 times 1, you get your 1. Over here, I to the 39th, what I did was I said I to the 36th times I to the third, and again you add the exponents to get the 39, but look at this. I to the fourth, you go through your multiplication tables of 4. 4 times 9 is that 36 times I to the third. And so every time you have I to the fourth, you replace it with a 1. 1 raised to the 9 produces the 1. See how you point out all those factors of I to the fourth? Take as many of them as you can out. What's left standing? I to the third. What's I to the third? We've already answered that, -1, and there's your answer. Okay, and example C deals with negative exponents. We deal with them the way we always had before. We write the reciprocal and change the sign of the exponent from a negative to a positive. So that's how you handle those, and I squared equals -1, so 1 divided by -1, -1, and we have done it. Okay, class, it took a little longer, but hopefully we did okay, and I apologize again on that 7A. It's in the book here if you want to refollow that, page 478. And yeah, what's the negatives? You know the deal. It's a squared plus b squared, okay? And we have finished 8.7. Woo-woo! We have finished chapter 8. Another woo-woo. Congrats to your hard work. We now are ready to enter into a quadratic equation and parabolas in chapter 9. We have lots of work to do. We have many pages of class notes and many videos to work on. So when I see you, I will be starting 9.1, page 1. Until then, take care. Okay, bye-bye.